GCF. GCF stands for greatest common factor. The greatest common factor is the greatest integer a set of values are all divisible by. You might remember this from back when you learned how to reduce fractions. To reduce a fraction, you find the greatest common factor of the numerator and the denominator, then divide both by that number. Finding the GCF ensures that all the values are divisible by the same number. Factoring means breaking down a product into the factors that multiply together to make it. Up to now, all the factoring you've done has been individual numbers. But, as you learned in the first half of this unit, you can also multiply polynomials to make other polynomials. That means polynomials can also be factored. So what do these two ideas, GCFs and factoring, have to do with each other? To put it simply, some polynomials are products of a polynomial and a monomial, and we can use the GCF to pull the monomial back out. Okay, yeah, that doesn't sound simple, but in practice, it totally is. In this polynomial, there are 3 terms. Each individual term has its own set of factors, but in order to fact something out here, we have to factor it out of the entire polynomial, all of the terms. So we find what factors are common in all the terms and pull them out. Just like that, we factored the polynomial. We found what we'd multiply together to make 3x squared minus 15x plus 6. Checking our answer is easy. If we found this answer by pulling out the 3, then we can test it by distributing it back in. 3 times x squared is 3x squared. 3 times negative 5x is negative 15x, and 3 times 2 is 6. If we redistribute, we get back to where we started, so we have factored this correctly. Here's another example. Now, we could factor every term to find the GCF every single time, but that's a lot of work, and it can get kind of exhausting. Usually, it's possible to figure out the GCF without all that work. First, what are all 4 coefficients divisible by? All of these numbers are divisible by 6. Is there anything else that all 4 terms are divisible by? Well, x to the 5th, x to the 4th, x to the 3rd, and x squared all involve at least 2 x's. So we could factor that out as well. Remember, since we're pulling these factors out of the original, the GCF needs to be divided out of the old terms. For the variables, remember your exponent rules. If we divide by x squared, it subtracts 2 from the x's exponent. The factored form is 6x squared times 3x cubed plus 2x squared plus 6x minus 2. And again, we can check our answer just by redistributing. 6x squared times 3x cubed will get us back to 18x to the 5th. 6x squared times 2x squared gets us 12x to the 4th, and so on and so on. Our answer is correct because these are the factors that multiply to make the original polynomial.